Greetings everyone from N2CUA, Randy here. What we're looking at on the Rigol DSA-815 Analyzer right now is a little experiment. My last video, this is sort of a part 2 of my video on measuring cable length with the Spectrum Analyzer that I had done for my son, Jimmy, which his call, by the way, is KD0MCI, not KC0. My bad. Okay, so what I tried this time was to see whether or not we could do the same thing that we did with coax, but in this case with Cat5 Ethernet cable, and apparently we can. One of the things I didn't know was, does Cat5 cable have a velocity factor? Well, you would think it would. I mean, there's insulation, there's capacitance between the twisted pairs, and there's inductance there. So my guess was there probably was, but the question was how much, and I didn't want to look it up yet. I wanted to measure the length of the cable, which I did. It's 80 feet, and then I wanted to find the point on the Spectrum Analyzer where the first notch is to see what the frequency was and calculate the length that way. And then from those two lengths determine what I thought the velocity factor was, and then look it up. Now I didn't only find one source on the internet, and it was really a forum comment about it, so I haven't really officially found the velocity factor, but what he said it was close to what we got anyway, so it doesn't really matter. So you should be able to read the display a lot better. I have a different camera. And the marker, I was going to say let me get my pointer, but it seems that my pointer has wandered away. So down here it says the marker frequency is 2.1525 megahertz, and that's at this dip right here, this notch. It's the first one that we see as you go across the trace right there. That first one is the one you measure. And keeping that in mind, I did some math. Hopefully this won't flicker. It did last time I tried this, but we're going to try it again. Okay, here's my math. So we got the frequency at 2.1525 megahertz. And we know our formula for quarter wavelength is 234 divided by the frequency in megahertz, which came out to 108.71 feet. Now, as I said, when I measured the cable, it came out to 80 feet. So then, using that, I divided our measured feet by the actual feet of the cable, divided by the number of feet that you'd calculate out using the formula up here, and came out with a velocity factor of 0.72. So then when I went on the internet, this one fellow on a forum said that the velocity factor of Cat5 is 0.70. So that's pretty close if you think about it. So then I redid the calculation as far as what the length should have calculated out to be with the 0.70 velocity factor, and it came out with 76 feet. So there was a 4-foot error across an 80-foot cable measuring it with the Spectrum Analyzer, and it's just for fun. I mean, there's certainly other ways to do it, and I believe that the network analyzers they have out there can measure how long a cable is with some incredible accuracy, probably. So, but again, it's just one of the things you can do with the Spectrum Analyzer, and this is a really good analyzer. I've had a great time with it, and I've done much with it. Very, 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 very user-friendly. Just so easy to use this thing. And now that hopefully we can see the screen better, I wanted to go through some things again really quick for you guys. I still have another couple minutes here. So again, over on this side, by the way, this preset, this is a factory preset. If that's what you have assigned to it, I should say. So if you hit that button, it goes back to the factory defaults, like a power-up default type of thing. You can assign different user setups to that key. So, if you're always measuring similar things and you want the span to be different and the preamp to be on versus off or what have you, you can set it up the way you want, save that setup, assign this preset key to that setup, that user-defined setup, and use that instead. That's fine. And this is our print key. Again, when you print, if there's a printer hooked directly to the analyzer, it'll print to the printer. If there's not, and you have a thumb drive in here, it will automatically default to printing to the thumb drive, which is a very handy feature. I like that a lot. Okay, and then again on this side of the screen is the status of all the different things you have set up on the scope. Like right now we're measuring peak, and I guess if we went over to the amplitude, Is that right? Oh no, it's not. It's trace. That's right. So it's trace type. Okay, I guess that is not it. But let's see. We got down here CW, which is clear right. CW. I could say well, let's do max hold. Now it changed to max hold. And you can also, by the way, I don't know if you can see it up here, but there's actually 3 traces you can have turned on. So we could turn on another trace, which is now set to blank, which means it's not showing up. And then you could do something like freeze. Now if you look over here for trace 2, it says freeze. So the idea is this gives you the status of each of the traces that you're using at any given point in time. And this bottom one is math, so you can perform math on the different traces. I've never done that, but I suppose it could be handy. This one here is preamp. If you go to amplitude, to the second menu page, and turn the preamp on. That one lights up for preamp on. Turn it back off. Sweep time. I'm not sure. It says ST. I'm assuming sweep time. I haven't looked it up yet. Not sure what makes that come on. And that is not it. So that's one I'll have to figure out. This one's correction factor. You can calculate in correction factors for different cable lengths or whatever. You got a setup and it's got, you know, a bunch of stuff in it, and you know with that setup you're going to have 3 dB of attenuation. You can add that in or take that away or whatever to what this analyzer is measuring to compensate. So that your readings come up to be accurate again. This says sweep is continuous versus single. If you went to round sweep, no, anyway. Oh, I can't do that in this for some reason on this particular setup. But if you switch it to single, single's over here, there's continuous and single, then that would just say single. And again, I've already told the rest. A lot of the information about what the settings are on the analyzer are already set up here. We have like a resolution bandwidth down here. Right now it's 100 kilohertz. Center frequency, what that's at, 1.75 megahertz. The video bandwidth, 100 kilohertz. Sweep time, span, which is frequencies from start to stop across the display. You got the reference level with the display, where that's set at, whether or not the input attenuator is turned on, and at what setting it's at. Right now it's at 0 dB. It can be up to, I think, 30 dB if I'm not mistaken. And then your marker, and that frequency with the marker, and also time and date up on top. And again, over on this side is your soft menu. And now we're up to 8 minutes here, so I'm going to go ahead and call it a day here. Hope you enjoyed watching. Hope you learned a little bit from it. And it's a really great analyzer, folks. If you only need to go up to 1.5 megahertz, which for us as ham radio operators, that's like most of us, that's the cat's meow. And if anybody works above 1.5 gigahertz, then they usually work way above 1.5 megahertz or gigahertz. So they're going to have to buy a much more expensive analyzer. But anyway, have a good day. 7 3s. Again, thanks for watching and listening.